this as your first attempt at this quiz. So we're going to do something a little bit different here that we've done. I'm just trying to think of ways to help you improve how you do on Fridays. What I want you to do when you look at these answers, I want you to give yourself a score. I want you to give yourself 0 out of 4, 1 out of 4, 2, 3, 4 out of 4. And let's see how you did today. Like if today were the quiz, how would you have done? And the idea, hoping that if you made 2 out of 4 today, the next day or two you'd make 3 out of 4, and then possibly by Friday you'd be looking at a 4 out of 4. That would be the goal. Some improvement. So here we go. Here is a list of answers. I didn't give any work here. I'd be happy to show you some work if you'd like. Just gave you a list of answers here. I think number 1 is 3. Number 2, I wrote the slope-intercept form and then graphed the line. And then number 3 and 4, just answers only there. So please give yourself a score out of 4. Try to figure out how you would have done it. So let's get better. Let's not be doing that on Friday. Yeah.
Does it matter which?
Oh, the order, like x plus 2 times 2x minus 1?
No, like if there's, oh yeah.
Yeah, if you just took the whole factor and just swapped it, totally fine.
Okay.
Yep, 100% fine. And that's the, I'm gonna math nerd it up here for you, Sebastian. That's the commutative property of multiplication.
Okay.
Within multiplication, the order does not matter. So, 7 times 8 is the same as 8 times 7. So, pretty good. All right, so you've all had a chance to see the answers. You've had a chance to give yourself a score, hopefully out of 4. So if you look at your paper now and you scored like a 1 out of 4 or a 0 out of 4, maybe a 2 out of 4, something like that, now would be a great time for you to say, whoa, I maybe got one of those right, but the other ones, not so good. Maybe this would be a time we have a conversation and I show you something or you ask a question or I don't know. So if you would initiate that by letting me know which one you want to talk about or see, now's the time. Chase.
Go over to number 3.
And which one did you, Mason? 3? Sure. Okay, so number 3, a couple of really key words in number 3. I'd say none is more important than this word right here. So let's stop for a minute and talk about what this is telling us. It's saying that we basically have 2 lines going on here, and they are perpendicular to each other. So before we get too far, let's remember what the relationship between perpendicular lines is.
They're opposite.
The slopes are opposite and reciprocal. So remember, opposite just means change the sign, and reciprocal means do the flip of the fraction. So to me, perpendicular is a very key word. I'm obviously trying to find the equation of a line. It says that right there in the first couple of words, right? An equation of a line. We're going to go to slope-intercept form. So let's take another broad picture of this. If you're trying to find the equation or graph of a line, what are the 2 things you have to have? Point and a slope. Very good. So would you guys agree with me that the point is not too hard to find? It's right there, isn't it? Hey, Mason, check out the screen. I found the point. It just said, my line goes through this point, -3, 5. So I honestly could do this. I want to see if this makes sense to you. I could start out by doing this. Y minus 5 equals blank times x minus -3. At this point, I could use point-slope form because I've got a point and I'm about to find my slope. I could do this. I just need to fill in the blank for the slope. So I've plugged in my point. Now my slope. I'm told that my line is perpendicular to this other one that I'm underlining in orange. So my line is perpendicular to that one. What's the slope of the orange line?
3.
That's right. And earlier you told me that the slopes of perpendicular lines are opposite and reciprocal. Not just opposite, but both. Opposite and reciprocal. So what's the...
1/3.
The reciprocal of 3 is 1/3, and the opposite of that is?
Negative 1/3.
-1/3. So over here in place of this blank, where my slope should be, I just put -1/3. So I've got a perfect point slope form for this at this stage. I just need to do a little bit of work to get this in the slope-intercept form, which it asked for. So I go here. y minus 5 equals negative 1/3 x minus 1. That's the distributive property. And then lastly, I add the 5, y equals negative 1/3 x plus 4. Come back around to that final answer. So Chase, Mason, both of you said, hey, let's talk about number 3.
Yeah.
I talked about it. Did that do what it needed to do, or do you
Yeah.
have any follow-ups?
Yeah.
Yeah, and
Fantastic. Okay, anybody else? Question on 1, 2, or 4? Let me come back to you. Oh, yeah, question. Number 1, okay. So number 1 is a PEMDAS question, an order of operations. So order of operations tells us that we need to do any work inside parentheses first. So I will do that. So I'm just going to copy down everything but what's in the parentheses there. Let's do the work in the parentheses. Do you see how it's 13 minus 7 times 2? 13 minus 14? What's 13 minus 14?
-1.
Okay, so I've done all the work in the parentheses first, right? Well, right now it's a -1, but I'm about to do an exponent. What's -1 in the parentheses squared?
Positive.
-1 times -1 is +1, right? So it'd be 6 minus 12 divided by 3 plus 1. Okay, so I've cleared all the work in the parentheses. I just did my exponent. So Mason, what comes next after P and E in PEMDAS? There's no M though, right? There's no multiplication. But there is division. So I'm going to do 12 divided by 3 before I do anything else.
4. 6 minus 4.
Now everything is addition and subtraction. I just go from left to right. 6 minus 4 is 2. 2 plus 1. There's my 3. Okay, any takers on 2 or 4? 4 is the newest, right? 4 is the factoring. That's what we've been working on for the last like 2 and a half, 2+ weeks, something like that. What's that? You want to do number 4?
Yeah.
Okay. So number 4 says factor completely. This is a nice transition from, you know what, I'm just gonna erase everything, give myself a little more room. So number 4 just says factor completely. So you have to buy into this, Mason. Check this out. We all have to buy into this. If you're going to factor, the first type of factoring, like the way you just get this started every single time, is to try to factor out what particular type of factoring.
8 times 8.
No. Morning. No, let's just keep focused, please. Come on. Not just Mason should be thinking about this. If you're factoring completely, the first type of factoring is you need to get the GCF out first. So Mason, you wanted to jump straight to AC, right? And that may or may not work. I need to think about a GCF. So I've got 2x squared, 3x, and minus 2. Is there a GCF amongst those 3 terms?
no.
There is not. So since there's not a GCF, now we keep going and we say, all right, we dealt with the GCF. How many terms are there? Is this a binomial or a trinomial? So if it's a trinomial, this is where we do the AC and the special box and all that stuff. So Mason, here we go. A is 2. B is 3. C is -2. Does all that make sense? Okay. So then I come over here and I do my little X to help me just organize my thoughts. AC goes up here. B goes down here. Thankfully, -4 is a pretty small number. There's not that many numbers that multiply to be -4. I got to think of the numbers that multiply to be -4 and add to be 3. Let me just give you some examples. What if I did this? Does this work?
No.
What's 2 times -2?
-4.
Does that add to be 3? Nope, so that didn't work. Bray, did you have an idea about what number should go there?
4.
4 minus, no. 3?
I'm just writing down whatever you tell me.
Oh, 4 minus 1.
4 and -1. So let's check. What's 4 times -1?
-4.
That worked. 4 times -1 is -4. And then how about 4 plus -1? It's 3. So you got it. Perfect. Okay, so Mason, what I do now is I take those numbers and help me with my box. Mason, you tell me what goes upper left.
2x squared,
What goes lower right?
negative 2,
What about the 2 empty diagonals?
4x, and negative 1x.
You got it. Okay, so now I'm going to factor the GCF out here. So what's in common on that arrow? I disagree. Should just be a 2 because the finishing box is positive. Go with the 2. How about this one? You said X? Yep, X is right.
C,
And then factoring along this blue arrow, what's in common? It's got to be negative 1 because the finishing box is negative. How about the one that I didn't put an arrow on?
2x.
2x. There you go. So there is your... Hey guys, I'm about to ask you what could be a very hard question. That's my factoring. Now listen, I so hope if you're only paying half attention, this might mess you up. I'm going to take that risk. Why didn't I do this?
Because it doesn't equal 0.
it definitely doesn't equal 0.
What did the directions say?
Factor completely. Not find the
And did you notice that? Did you notice that that's not an equation there in that red box? And it said factor completely. So at that point, right here in this other red box, I have factored completely. It didn't say anything about solving, so I'm not going to be solving anything. And there's not really even anything to solve because there's no equation, right? All I really can do with this is factor it. So that's why I didn't do that. All right, why don't you guys grab a computer and get to this screen right here. Hi.
I can't be on any electronics.
You have what?
I can't be on.
Oh, that's fine. We'll do our best. Please do try to explain yourself. It might be hard to explain yourself. I don't know. Just explain what you were thinking when you tried to do the first place.
What are you doing?
Okay, so let's talk about what the answer is and let's look, I'm going to try to show you as many of these explanations as I can. So first of all, the correct answer is -3 and 3. Okay, both of those numbers are solutions to this particular equation. Take a look at, maybe you didn't see Anya's explanation coming through because you only get a handful of them, right? I would say here that essentially, and you can correct me if I'm wrong, but as I read what your thinking is here, it looks to me like you almost like did like an intelligent plug and check.
Yeah.
You plugged it in. Hey, look, I square this, I square that. 27 minus 27 is 0.
Yeah.
So she kind of plugged in. Let's look at some of the other answers here. So Bray also got the correct answer, and he says you have to find the GCF to solve it of 3x and negative 27. The last part's a little confusing. Maybe, I'm not sure what the word of is doing there. But he said, I need to factor out a GCF. And you're going to see that other folks did that too.
I'm gonna change it to that.
So Bree says, use the GCF and it cancels out, making it 0. Again, she's trying to use the GCF. I don't know about what's canceling out exactly, what's being made 0. But you're thinking about the GCF. Thinking about the GCF could work. Caroline says, I factored out the 3. Then she must be in the middle of writing something right now. Oh, Chase writes, factor out the GCF, then solve with the difference of squares. That's a pretty clear explanation. We could definitely do that.
Yeah, Chase.
Ellie says you have to find the GCF. It gets you 3x and negative 27. Then solve to get so she's doing a GCF as well. So I think that's a good move. Julia says GCF, then break apart the squares, the difference of squares. Also makes sense. Kate is focusing on factoring out the GCF. Okay. Looks like, Mousenesis is going sort of like a similar thing to Anya there with like a plug and check idea. Makes sense. Oh, look at that. Noah did the same thing. He's like, hey, I'll plug it in and check. That makes sense. Oliver found the GCF, then he's sort of drifted off there. Maybe he's in the middle, writing something. So Sasha, she just says factor the expression. Wasn't specific about what type of factoring, but that could definitely work. Sebastian did the plug and check. Sophia mentions the 0 factor property, the GCF, breaking apart the difference of squares. All good ideas. Definitely works. GCF from Sydney. Makes sense. GCF and factoring. Trevor wants to think about a GCF as well. Okay, this is great. So what I'm going to do here is... There we go. Hey, I want you guys to check this out. Let's do this. We're just going to pause for a second here. And I would like to show you... Listen now. I'm going to show you a different, and in this case, better and more efficient way to solve this equation. See if you can follow my steps. Now, this only works in certain situations. This is one of them. Okay? So check this out. If I took this 3x squared minus 27 equals 0, I want you to notice something really key about this. And this is, again, about, remember how I've just talked a lot about, hey, I noticed this. Therefore, I could do this because this is true. This is logical. I'm going to notice something. I want you to notice it with me. This is a nice quadratic equation. What's the A value?
3.
A is 3. What's the C value?
0.
C is negative 27. Remember, a quadratic equation is, please check this out. Watch. AX squared plus BX plus C equals 0. So notice how there is an x squared, right? AX squared. Check it out. A goes with 3, does it not? A goes with 3. Notice how the constant is right there. Notice how there's no bx. There's no x to the first term. So if A is 3 and C is negative 27, then B must be 0. 0x is 0. We wouldn't even write that, right? Okay. So the thing that I'm about to show you pertains to when B is 0. You with me? You guys know the difference between a flathead screwdriver and a Phillips screwdriver? Wouldn't it be silly if there was a flathead screw that you were trying to tighten or loosen and somebody's got a Phillips screwdriver just like trying to... It's not going to work. So, now listen, the thing that I'm about to show you only works really well when B is 0. Are you with me? So don't try to use this on everything. This is a really good tool in your math tool chest. but only use it when b is 0. Here we go. Here's an easier way to solve this one. First thing I'm going to do is add 27 to both sides. 0 plus 27 is 27. Then I'm going to divide by 3. I'm trying to get this x squared, the squared quantity by itself. When I do this, I get x squared equals 9. Does anybody have any ideas about how I could get rid of the squared? Because I'm trying to get this x by itself. What could I do? Doesn't a square root both sides? Doesn't not square both sides, square root both sides. Doesn't a square root cancel out a squared?
Oh, yeah.
So here we go. I'm going to square both sides. Of course, that gives me x over here. Now, there's a good reason for this. But whenever you square root both sides, you have to consider both the positive and the negative square roots. So I would put plus or minus 3. So that sometimes is a symbol that people are unfamiliar with.
Why if you do it this way, is it plus or minus?
So what's 3 squared? I'll write this down. We're checking our answers now. What's 3 squared, Mason?
9.
What is negative 3 squared? That's essentially what some of these folks did that just guessed and checked, right? They just plugged in and checked. They said, hey, 3 squared is 9, negative 3 squared is 9. Well, times 3 is 27, and 27 minus 27 is 0. So they found by plugging in that either the negative or the positive of 3 would work. Okay. So this is called solving using square roots, and it only works when b is 0. Hey, listen. I can show you a Phillips screwdriver. I can show you a flathead screwdriver. But when you don't have a clue when to use it, it's not going to do you any good, right? So the only time that you're going to use this method, when it's going to make sense, is only when b is 0. So if you guys would, I'm going to unpause this. And I want you guys to, this next one will be a little bit tougher. Let's see here. Yes, please move on to number 2. Number 2 is a little more challenging. See if you can use some of the same principles to help you figure out number 2. Number 2 is going to flow along fairly nicely. You can only use this square roots method when there's no b. b is 0.
And also 9, because 9 minus 4 is 5. And square is also times 5. Use this method because we
Love your answer, Mason. And I'm being sincere, like, being very sincere because the solutions to an equation should work. Honestly, they should. The only challenging thing I would say, Mason, is that if you were presented with a question like this and it was not a multiple choice, could be in trouble, right? I'll show you a good technique on this one in a second. Take just a moment or two here. I'll give you a good couple of steps here. This will be something we practice again tomorrow. Hopefully you'll have a good handle on it today, but if not, tomorrow, hopefully that'll happen. Okay, so let's see here. Anya says, I'm just looking at explaining your thinking. She says, you plug in the factors, then solve the equation. Bray says something about a GCF. I don't think there's a GCF here. I'm not sure where you'd go with that on the GCF. Reed didn't explain. Ellie says you find the factors, then plug them into the equation.
I know.
Julia says something about getting 40. Oh, you get, okay, they equal 46, which is the right side. Okay. Kate says if you plug it in, you get the answer. We already saw Mason's. I think you plug the numbers in to equal it in. Sasha, no idea. So you just like randomly guessed. You closed your eyes and just picked one.
Sosh.
What?
Well, no, I just did like the other method, and that's why I got like you said -3, but you can only do that when it equals it. So.
Okay. Let's. So when I show you the method here in a second, let's look really carefully about what you did and see if it makes sense or not. So Sebastian says plug it in and solve. Sophia says when you plug, you do get 46. You plug it in and it works. Okay. Hey, so I want to applaud you all. Like as far as explaining your reasoning, like if you just said, hey, I plugged stuff in and they worked. Really, that's at the heart of what a solution to an equation is. You should be able to plug it in, and it should work. Because if you plug it in and it doesn't work, it's not a solution. That makes sense? But like I mentioned to Mason, if your only method for solving an equation is I tried to plug things in, you're going to run out of gas really fast if it's not a multiple choice, right? So here we go. Let me show you a good method. This will go along nicely with what I showed you just a minute ago. Here is my starting equation right here. Can you guys see how it almost looks like somebody's factored this already?
Mm-hmm.
Do you see how somebody went through and did some factoring before you showed up? That makes sense? That x minus 4 quantity squared, it looks like it's been factored to some degree. So here are your steps. We want to, just like we did before, we want to get the squared quantity by itself. So you better either have a really good memory or you should be writing this down somewhere, really paying good attention, because here in a minute we'll do some others that are like this. So if I was going to try to get the squared quantity by itself, do I need to get rid of the minus 4, and this, I'm referring to this one. Do I need to get rid of the blue, or do I need to get rid of the yellow first? Which one do I do first? I got to get rid of both.
Yellow first.
It's blue first, right? Don't you have to add stuff to both sides before you divide? So I'm going to add 4 to both sides. There's that tendency to want to get rid of the yellow because it comes first, but you'll always get rid of addition or subtraction first.
Do you have to do PEMDAS on this?
It's actually reverse PEMDAS.
Yeah, right. Reverse.
Well, so, doggone it. Here, hang on, move, please. So, Bray, let me just try to draw a parallel for you. Remember back to first semester, if you saw this What would you get rid of first, the 3 or the 5? Do you see how the minus 4 is like the 5?
Yeah.
So that's why we...
Do in parentheses first or something.
So we're not simplifying, we're solving, right? We're solving. So I'm not going to do any work inside any parentheses first. I'm going to be solving. So now how do I get rid of that 2?
He types it into the. Oh wait, that's not.
If you were going to do that, now you're simplifying.
Yeah.
And if you were going to simplify, you'd have to do the exponents first. Sydney, you said something. You divide. Goodness, please pay attention. Or don't. If you choose not to pay attention, you'll be needing to do a lot of retries over this material. Okay? Please pay close attention. X minus 4 squared now equals 25. Now, this is kind of the same stage we got to with the previous question. How do I get rid of squared? Square root. That's right, both sides. So I square root the left side, and I square root the right side. So I get x minus 4, because the squared and the square root do cancel each other out. What do we get on the right side? Not just 5. Yeah, I've got to consider both the positive or the negative square roots of 25, so I get plus or minus 5. Here are my last couple of steps. I need to add 4 over, so it's 4 plus or minus 5. And this is where you're going to come around to those answers. This would be 4 plus 5 or 4 minus 5. 4 plus 5 is 9. 4 minus 5 is negative 1. So those are your two solutions right there. Excuse me. Okay, let's do a couple more minutes of practicing here. Hopefully leave you in a good place before we head out. So flip over to your packet. These are all in there. There's 2 of them. There they go. Hey, you're going to find that number 1 is just like the one we did at the start, and number 2 is just like the one we just did. So please, take a moment and try. Neither of these is multiple choice, so if your strategy is I plugged things in, it's not going to go very well. You're going to have to use those techniques that I showed you. Take 2 minutes and try. Let's go.
Oh, do you?
Your first step, you want to get the x squared by itself. So instead of bringing this over, you need to subtract this over.
Oh.
You're like what you're doing there is you're trying to get more things with the x squared. We want to actually be getting things away from it.
X squared equals.
There we go. Uh-huh. No, you were close. You need to get the x squared by itself first. Notice how here the x squared is not by itself. It's got that 5 there.
All right.
So before you attempt any square rooting of anything, you want to get rid of the 5.
You want me to divide by 5?
That's right.
Okay. Yeah, that makes sense because that's squared to 35.
Sure.
Is it real?
Even if it is an ugly square root, you got to get that x squared by itself first.
So this would just be the answer.
All right.
Don't forget when you square root both sides, plus or minus. Yep.
35
Outside the square root or inside?
Side.
should be x squared equals 7, and then you would square.
Now is the time when you square root. You got it. Okay, you're super close. Hey guys, I want to make sure that number 1 is one that we are comfortable with. Let me show you a couple steps here, and you can give yourself, credit here on number 1 if you do it correctly. So now, please. So here we go. Your first goal is to get the x squared as by itself as you can. So I'm thinking that I would subtract 4 from both sides. Is the x squared all by itself now? Nope. What do I need to do? Divide by 5. Yeah, get rid of the 5 by division. So when I do that, I get to x squared equals 7. Now is when I get rid of the squared. This is the square root of both sides time. So I square root this side and I square root that side. So if I were to write this, am I fully correct?
No.
What did I miss? Plus or minus, right? Whenever you square root both sides, you've got to consider both the plus or the minus side of the square root.
Is that it?
So number 1 is done. Yep.
So
X
you can't square it, it just stays squared.
So 7 is not a perfect square.
Uh-huh.
So if it was like plus or minus the square root of, say, 25, you could say plus or minus 5. If it was the square root of 100, you could say plus or minus 10, right?
Yeah.
But 7 is prime, so you just leave it as plus or minus square root of 7.
Okay.
Hey, let's do number 2 together. I'm hoping that by the end of class tomorrow, you're really good at number 2. Let's see what you can do with number 2. What would you suggest as a first step? Come on, hey.
The 4.
What do you subtract 4, correct. So I go minus 4 from both sides. This gives me 3. Y minus 1 squared equals 9. What would you divide by 3? Good. So division by 3. This would give me y minus 1 squared equals 3. Now what?
Square.
Not square.
Square root.
Say the whole thing. Square root. There we go. So we square root both sides. This gives me y minus 1 equals what? Not square root of 3. Plus or minus the square root of 3. And then my final step would just be to add the 1 over. So this would give me y equals positive 1 plus or minus the square root of 3.
That's it? You done?
Done.
Nice.
Yep, we've left our answer in a good form, so we're good to go. All right, we'll keep working on this tomorrow. Have a good rest of your day. Don't forget you have your concept quiz tomorrow on solving quadratics with factoring. So practice. Practice, practice, practice.
Another concept quiz.